automation and controls engineers from Chicago, Illinois.
We all work for the same consulting company, DMC.
We've been automating machines together for over 3 years. We are
the Control Freaks! We want to be on junkyard wars because we have the guts, the energy, and the brains to turn your junk into winning designs.
As automation engineers, we exercise our mechanical, electrical, and analytical skills every day.
We pull together to solve real-world engineering problems that others can't.
Leon is our team's captain. He's a chemical engineer and our team's fluids expert. His previous experience includes research for the Department of Energy and a major oil company. He spent a great deal of time in his family's second-hand business concocting contraptions out of junk. If you need something created out of thin air, Leon is your man.
Ken is a mechanical engineer and a senior member of our team. He was previously a diesel engine designer for a major manufacturer. He is our team's engine expert. Ken was on his school's racing team in college and knows a lot about bodging things in a hurry. He is a math genius and is the go-to guy for calculations and approximations.
Tim Yeager is a mechanical engineer. His hobbies include amateur filmmaking and mechanical tinkering. He has his own machine shop and welding equipment. During college, Tim was the leader of his school's solar car team. He is also our team's electrical expert.
Here we are in the lab to explain how an air conditioner works.
We're going to be demonstrating the principles of compression heating and expansion cooling using an ordinary air compressor.
To help us out, we will be using a high-tech thermal imaging camera, which displays an image based on temperature instead of light.
As you can see, the hotter areas, like our faces, are displayed in red, whereas the colder areas, like the wall behind us, are displayed in blue.
Compression is the process of taking a large volume of air and squeezing it into a very small volume of space.
This compression process requires energy.
The energy gets transferred into the air and makes the air that was compressed hotter.
This portion of the air compressor compresses the air through a tube up here down into the tank below.
As seen in this thermal image, the top of the compressor gets very hot. This is due to the heat of compression.
Now that we've turned off the air compressor, we're going to let the gas inside cool off to room temperature, but it'll retain most of its pressure.
We're going to allow the pressurized air to flow through this small nozzle and go back to atmospheric pressure.
Just like when we compressed the gas and it got hotter, when we let the gas expand, it'll get cooler.
Since the gas is already starting at room temperature, when it gets cooler, it will cool to a temperature below room temperature.
Since our thermal camera cannot detect the cold air, we're going to cool off a piece of room temperature notebook paper to prove that it's cold.
All right, Leon, open the valve.
Our thermal camera shows that the dark spot is 12 degrees below room temperature. That means that we have successfully created a crude air conditioner. Now we're going to describe how a real air conditioner works. The main difference between a real air conditioner and our air conditioner is that a real air conditioner recirculates its coolant continuously. Here is a diagram of a standard household air conditioner. You have the basic components, the compressor, the expansion valve, the heat dissipation coils, and the air conditioning coils. The refrigerant undergoes compression heating in the compressor. The heat is dissipated in the heat dissipation coils. The expansion valve causes the refrigerant to undergo expansion cooling, and that cool refrigerant is then passed through the house. A fan blows over the coils, cooling down the house and heating the coils up, where the heated refrigerant is passed back into the compressor.
Hi, we're the Control Freaks, and today we're going to turn this pile of junk into a ridiculously huge beer mug.
Got the torch.
I got the welder.
I guess I'll go get the beer.
mark just disappeared in the soot.
Get the torch all the way.
Very nice.
The dots here, since it kind of... Alright, I'm going to finish the last third of this cut. Probably want to get in on that.
Are we going to put our bead on the outside or the inside?
On the line. Bead on the line.
No. Bead of the welding.
Oh, the bead will be on the outside. But in this case, we want to cut on the line.
Which means
the line,
we want to cut along
No, the line is too big, remember. I traced around the outside of that sucker. So if we cut on the line, the thickness of the cut is approximately the thickness that if we just cut on the frickin' line, what's left over will be the same size as that, and we'll be able to make a really nice weld.
Sure. I'm going to cut the second third of this base for our beer mug.
I realize starting where you work in.
Tim, are you going to cut the whole thing?
Yeah.
All right.
That's the best so far, is right there.
You wanna mark it?
Yeah, all right. That's fine. So is this grinding shaft.
I do any.
Now I'm going to weld the bottom onto this extremely large beer mug.
How's it going?
Yeah, you don't want to miss.
Tomorrow, but Ken's gonna be in Milwaukee. We may want to cut another one of these out, but we want to do it quickly.
Unless, I mean...
We have enough video of cutting and what we do.
So just put that down.
Well, we want to put a handle on it. Make it pretty good.
Get some other...
Maybe we could do some random cutting footage or something.
We should put us off cutting the rebar.
Right, yeah.
Probably
It's a big freaking hole in film here.
I think
What?
it's- Yeah. Yeah, 115. So, right. We gotta get the tanks back to close at 4, right? And I'd like to get, if we do it downtown, I'd like
All right, it should be watertight now. Go for it, Tim.
Is it still watertight?
Alright, I'm going to patch the holes and then we're going to try it out again. It's definitely watertight now. You can bank on that.
Oh yeah.
Look at that.
Closer into the IV. Right next to that.
That stuff takes a lot of heating before it finally starts melting away.
There's a big gap of that about to fall.
Now, try to melt them together. Weld them together with torch.
We also want to get rid of your big gob on the bottom.
Big dot on the bottom. Actually, if you rotate it the other way, you take the big dot. That's really that way.
You gotta get right down next to that stuff and let you go.
Well, I'm just trying to heat up now. Not trying to start it yet.
do you think, Leon?
It's pretty good. Kick-ass handle. Oh, you got it off. This is half our beer mug.
Make it all at once. Good deal. Okay, now.
You want to do the filming, Tim?
Here we go.
All right, you can do that. All right. A hard day working the scrapyard sure has its rewards. Now, who's going to drink out of this thing first?